I will speak in English because I like to torture myself. So the topic for this evening is NoSQL journey in Oracle SQL world. So let's start by asking who knows the definition of NoSQL? What NoSQL is? Great! So what NoSQL is?
Not all the SQL.
It's a complex question.
Yes,
NoSQL is not SQL.
So reliable sources tell that there is no prescriptive definition of NoSQL. Instead, there are a set of properties that are common for many NoSQL databases. And one of those properties is being schemaless. So a better topic for this talk would be a schemaless journey in schemaful world. So, but NoSQL is a better buzzword, so let's stick to NoSQL. So, some background. I work for Tieto, and Tieto is a really large company. It covers different business areas, and I represent payments and cards area. And we are special because we are kind of like a product company, and we build a product called Tieto Card Suite, which allows banks to issue cards and to process card payments. So, and this product runs on different kinds of commercial Unix and Linux platforms. It runs on Oracle Database and Oracle Tuxedo, which is kind of like application server or middleware. And most of the software is written in C++ and SQL. There are also some parts in Python, Java, JavaScript, and so on. Now, yes, and so these technologies were chosen even before I joined the company, and they are still like relevant in the finance industry, although for the rest of the world they are kind of like dinosaurs. So then, why NoSQL? And it's like a common question from new employees, and we also have discussions like that internally. So there is this book written by Martin Fowler, who is a really good specialist, and this book gives like two main reasons for using NoSQL database. So number one is that it allows you to improve developer productivity, and the second is that it also improves performance in like different ways. So these are like two main reasons. So let's like go into details. So, and I'm like about performance, I'm kind of like showing off, but we did performance tests in Oracle Laboratory last year, and so we reached 10,000 transactions per second, and that's like 10,000 business transactions that involve also cryptography, using special hardware devices for cryptography and so on. But like, is it a lot?
Yes. What hardware?
No, the hardware is like this Oracle supercluster.
How expensive?
So to give you a frame of reference, so these are numbers from like similar areas. So Visa network in 2011, they had different sources, and they told like 2,000 or 3,000 transactions per second, and they like probably they are doing something like 5,000 now. So PayPal was doing hundreds of transactions, and then there's this cool new technology, and everyone is excited about Bitcoin, but Bitcoin is limited to only 7 transactions per second, and that's our like hard limit. So like performance is pretty good already. I know that this supercluster is a big machine, but if you reduce it 10 times, it's still like enough transactions for like most of the countries. So then there's like a second feature or property, and that's like productivity. And so our software is connected to like 500 financial institutions and banks. It works in like many countries and in different areas. And then there are like of course, every institution has its own rules about like business logic, and there are like different rules for when a transaction crosses different regions and so on. So, and even if those institutions don't like ask for new changes, there are still like changes from Visa and MasterCard at least twice a year that we still have to comply and give a new software to customers. And these are like external drivers, but there's also this software product lines idea, and we like try to follow it. And the idea is that we try to build reusable components, and we try to use a single code base for all those customers. Of course, it's like not so simple, but the idea is that the core of the product is like a single code base, and we with some configuration we adjust that for different institutions. So, and what I'm trying to say is like, yes, like this feature definitely sounds interesting for us. And then the like reality kicks in. It turns out that we still need NoSQL, like still need SQL. The number one reason is that we have to do reporting, and there are no like good reporting solutions for NoSQL world, and NoSQL solutions typically have a regular relational database installed somewhere nearby just for reports, and they transfer the data from NoSQL to SQL to do reports. So the second reason is like investigation. Like a customer has some problems, we can send him a SQL query to get the results. Customer also can use like bunch of tools just to look at the data, what's inside the tables and so on. So it's like very useful. We also use SQL for integration with other parts of the system, because SQL often is like the only common language that all those systems speak in. And this integration typically is like read-only integration, so other systems look at the data but they don't modify the data. We like use service-oriented approach for like the modification of the data. And then last but not least reason is that because actually customers demand it. So many customers ask for, they just like demand a big commercial database. So it can be like Oracle or IBM DB2 or even Microsoft database, but they want such a database because it like shows that the product itself is solid and serious. It's like a serious business. Then also like indirect causes that customers ask for a data dictionary, and they don't use that data dictionary all the time, but it somehow gives them comfort that they know what kind of data is inside the database. And there are also some non-functional requirements which ask for ACID transactions, which basically limits us to the, like relational databases. So we want the features of NoSQL database, but we are stuck in the Oracle database. So what to do? So let it sink in for a while. So we will do something like NoSQL inside the SQL database. So we can use SQL to like query the NoSQL data. And this also means that we will do something other than we are taught in universities or by the textbooks or like best practices of relational databases. So, and I will start with like simple things, and they might be boring, but in the few slides that it will be like more interesting. So first, many customers ask for things like, they call it free fields, which means that they are like some customer specific, like fields where customer can enter like specific information. And they don't specify what kind of information that they will enter there, they just want the fields to be there. And they want such fields on like person records, bank records, credit card records, agreement records, and so on. So what we did initially, well, we did exactly what the customer asked us. So we added like arbitrary fields named like code1 and value1, where code means that it comes from some list of values, and value is just you type something in. And then we add such fields to like reports, UI, and also to like online interfaces and file interfaces. Now, this immediately, like, it smells. The smell starts with the public API, because you know that whatever you put in the public API, it will stay there for tens of years. So, and like if you follow the clean code principles, then putting in values like fields like value1, value2 should make you uncomfortable. The other thing is what happens in customer support. So suppose customer calls in and tells like, you know, we have this report and the field with job title is truncated, or it's overflows the report margin and so on. And then you have to think like, wait, but we don't have a field like that. And then it turns out that actually customers uses value 3 to enter the job title. You have to do like this mental mapping, and you have to do it for each customer we have. It gets worse over the time. So, and because like at some point customer will want to have some like fundamental functionality based on this arbitrary field. So in typical cases, like for example, oh well, we want to do interest calculation based on value 2. So when we offer, well, wait a bit. So we will add a new field just for this interest calculation, and you will be fine. And then customer says like, no, but we already have information in this value 2. We have done integration with our call center, with other companies, and it's already taken. So what to do? You write some, can I say shitty code? But you write something ugly. Anyway. And then that gets even more interesting when the second customer asks for a similar feature, but this time he wants to base it on completely different field. And when you ask like, well, we have this feature, but it works on value 2, can you please use value 2? Oh no, it's already taken by some other kind of information, and it's also, integration is done, it's already like, so it gets ugly. Now, the interesting thing, in 2008, a company behind Salesforce published this white paper where they described how they use the database for their platform as a service. And this paper showed that we are not the only crazy ones. There are people who are even more extreme. So, oh yes, and this Salesforce in 2008 had like 47,000 businesses using this platform. So it's like pretty tested in the field, it's like really solid. So how they stored the data? All data was stored in a single table. It had like some global unique ID. It had organization ID to which the data belonged, and then they had like 501 value. So, and it's like, we know that this like leads to a complete nightmare. So how do they manage it? And the key to that is metadata. So for each organization, they had like multiple metadata sets where they like assign a meaningful and human readable name for each of those 501 fields. And then of course this platform does the whole mapping from this logical name to a physical name used for storage. Okay, now, and if you have used databases, you know that for good performance you need to have indexes. That's like the way you do. So what are the options here? Like, we don't know on which fields we will need indexes, so one option is to have like 501 index. but it will be like a storage nightmare and so on. So what did they do? They introduced like a second concept, which it's called index tables. So for each value that they wanted to store in index, they, how to say, behind the scenes in their platform, they also added a record to this index table. And they stored the value in the field of correct type, so they have like better performance gains. So, yes, and that's their success story. Except, well, it sounds interesting, there are some interesting ideas, but like they didn't know what kind of data they want to store in their platform, but we kind of do know what kind of the data will be. So we can use some ideas from that and maybe like not use that on a global scale, but on some small parts of the system, maybe. It was easy for them to do because they had like this whole platform that handled all the magic mapping from two fields and storing it indexing. When you query the data, they know that they have to go to another table, look into index and do all the mapping. So they like didn't use SQL directly. Like we want to use SQL, we know how to use it well, and we can get a good performance. So what to do? Like the next idea is to have these attribute tables, where you have like ID, which is like logical record ID, and then all the fields are stored like in self-describing structure with kind of like metadata in it, like name and value pairs. And you can use this structure to represent any kind of object, any structure of objects. Trust me, I know. But like, we also know that this is like a kind of like probably stupid idea. So what we do is like, if you remember the first picture, then we have this data table where we have like fields that we know that all customers need to have, and then for those customer-specific free fields, we started to use those attribute tables. So we store the base of the information here, and then the rest, instead of storing in like code 1 and value 1, we store it with like meaningful name and attribute table. Of course, like that produces some kind of problems. So the main problem was the size of the data. And well, if the size is bigger, that means that the object doesn't fit into memory, it causes larger I/O, the database works slower, and so on. So the reason for that is that on the right there's the table with data, and on the left there's like index. And what does the index store? It stores the ID and the name, and it clearly duplicates the same information which is available in the data table. And index also has this pointer to the real table, so depending on how large the value is, it's well, index is almost the same size as the table. So but Oracle has this nice feature called index organized tables, which really is an index that looks like a table to the users of it. And there's also like a compression option, which means that like in this table, instead of repeating this ID 2 times in the index, it will store it just once. I don't know the details, but like this compression really helps. We tried it out. There are like also other problems. In case we want to search by these values, we have to index them. But if we index them, that means we index all of the values. Even if, like in the previous slide, if we want to index value of bar, we eventually will also get the full values of full also in the index. But that's okay. Like we know, like from the previous examples, that we can build like index tables if we need it or not. And then there's also like this expectation when we try to integrate with some reporting and so on. Well, like all reports and if we integrate with third-party systems, they all expect that we have data in rows with many columns and not like many rows with like 3 columns. So this expectation is that we somehow pivot the records so they become like regular table. Now, the way you do it in Oracle is something like this. This is what Oracle experts suggest. So like, yeah, I probably didn't mention, but this attribute table is also like not a unique idea. There are systems which should remain unnamed that use this approach as well, which were not written by us. So, but like this is how you do it, and it like actually it works like pretty fine if you want to work on like a couple of records and so on. If you do like SQL developers are known for their ability to write like these large SQL statements that join 10, 20 tables together and that cause like performance problems. If you give them something like this, then the performance is gone. It doesn't exist. So, yes, you probably noticed that I mentioned like more drawbacks for this approach than for previous one. But like if you have modern hardware and for like some static, we could say like master data about like persons, cards, and so on, it actually works pretty well. It's not a like huge performance problem. But like our system not only has this master data, we also process transactions. And for transactions, well, transactions come in completely different formats. They have almost nothing in common except that there are some values that look similar, but they have like typically different names, different limits on lengths, and so on. And years ago, we tried to store those transactions just like they teach you in university. So, and I just did some digging yesterday. So it turns out, like, for example, Visa interface had, so it translated if we create a table for each type of record, it turns out to be like more than 500 tables with up to 50 fields for each type of record. So just for having Visa interface and doing the database, this structure as we are taught in universities, that's 500 tables. For MasterCard, it's like about 100 tables, but like up more than 200 fields for many of them. So if you have that many tables, you have to write code that manages those tables and selects. I'm not even speaking about those like business logic and hidden relationships between those 500 tables. It's like nightmare to manage. So what to do? And now we like jump into like classical NoSQL solution, which is called KeyValueStore. So we can represent again everything by having a key field and then a value field that stores like all the information we need. Is it a good idea?
Yes.
No.
No, why?
No, because we have used relational databases, and we know that we can like extract at least some kind of information, like for example, like what type of record is this, what is the status, is this like payment still in flight or has it been processed, rejected, where does it come from, when was it created, so we can do archiving and so on. So we kind of like make this structure a bit more like complex with more fields. Now, this value, we have tried different formats, like we tried to serialize in some funky ASCII notations and so on. We have tried XML as well. And so now what we like, most common format is something like this. It's like very, very readable, right? But this is actually a serialized message from this Tuxedo platform. This is like native Tuxedo message, it's just dumped into database. And it's easy for like programmers to use it because they just store the value, just read it in, and you continue processing. But this leads like to another like classical NoSQL problem, which is like this. Can you read it? So the idea is that we want to query something that stores in a database. Well, you don't write queries, you write some distributed MockReduce function in Erlang. Like, did you tell me to go F myself? Yes, I believe I did. So the idea is that we don't want to write some code each time we want to look at the data. Oh yes, and I also have to mention that this doesn't cause problems for like 90% of the tasks we have to do. But then there's like, sometimes we still have to see what's inside the message. So what to do? Like we do what NoSQL solutions do for reporting. We just transform the data from NoSQL storage to SQL with normal relational tables. So the benefit of that is like that we don't define all fields in relational tables, just the ones that we need for reporting, and the rest is stored in this glob value. And it works fine, and so we can probably do almost everything with it, like almost all functionality, but then there's always those like little things that break everything. So there are like some fraud cases where like that have, yes, so this is great if you have to do reporting like once a month or once a day, but there are like these fraud cases where you have to investigate them immediately. So what you do, since you have ETL, you can do like real-time ETL. So as soon as we have some value in this NoSQL storage, we like immediately push it to like SQL storage. And first we do like every 5 minutes, but then turns out that the operators who want to investigate those cases, they are faster than 5 minutes. Like the red light goes on and they want to see the transaction immediately. So we try to do it even faster and faster and faster and faster. And like at some point we have to ask like why? Because like it kind of like defeats the initial idea that we will have this arbitrary data, and now we are like taking this arbitrary data and immediately transforming into some relational data store, which is like it's like doing the same work twice. So what to do? It turns out that this problem is like solved like years ago in like NoSQL world, and it's called the document store. So document store is different from KeyValueStore in a way because the database knows what kind of data is stored like in this value field. And it turns out that now in 2017, JSON is supported in like 3 major big commercial databases, like this guy told before. Even Microsoft Server has it, and it's like it's also available in open source databases, and even like SQLite has JSON extensions. So what it allows to do is that we can write queries and like get the data from some JSON encoded values simply by using this dot notation. So the value is stored as JSON, and then everything that follows is like a query for a JSON structure. Now, and there are more features. We can create indexes on JSON data, like regular Oracle function-based indexes. And this is like feature which was all NoSQL databases were very proud at some point. They told like, we support secondary indexes. Well, it's like nothing unusual in relational databases. We can also use like the full power of SQL, so we can write SQL that joins that JSON data. It also like we can do some aggregation, calculate statistics, and so on. So we can use almost everything that SQL provides. And for integration with reporting and with other systems, we can create views on that JSON data that look like just regular relational views. And of course, the document stores and then key value stores have their own problems. One of them is that you can't update individual field in the document. You always update the whole document. Most of the time it's fine because document is consistent. Sometimes it does not help because it introduces some contention on updating this document. It's one of these major problems that we experienced so far is that JSON itself is a typed data format. There are types like number, string, and then there are complex types, so objects and arrays. Well, if you use JSON in SQL, then any value, regardless of its type in JSON, it is basically a string. And it's not a huge problem, but it can cause performance problems if you do joins using field store in JSON and some regular table where the types don't match. Let's say some other primary key is integer instead of string, then it causes performance issues. Now, that's I'm mostly done with the content. So to recap everything, first we had this tables with arbitrary fields. The main benefit was that it was as close as you can get to regular relational table. But to make it maintainable, you had to define some metadata. Well, with attribute tables, we kind of got rid of this global metadata, and instead we stored this what we could say metadata in these attribute names. And compared to attribute table, key value has much better storage properties because everything is stored as a single row. It means that there's a single entry for each row in the index, which means that the index is smaller, and Oracle, whatever database has correct statistics of how many rows of each type there are. And then we looked at this document storage, which kind of avoids having export transform load process. So I want to mention that in those performance tests I showed you, actually the first three approaches were used in different places. They were not used in the crazy way that this Salesforce does, but there are we used it on a smaller scale. This last document approach is since it comes just with the Oracle version 12, it's still in development, and right now we are building a new product that will use it. So, key points. First, I want to remind that there is no silver bullet. I showed probably for you that something that is completely crazy, because unless you have many customers and you experience all those change requests and all those changes and all the changes that touch the database and you have to do database upgrades, you probably don't feel the pain. And so it helps for us. It probably produces some problems as well, and only time will show if it paid off. So actually, a relational database is a great single node NoSQL storage. Why? Because it has the whole powers of queries, transactions, and indexes, and so on. It also it's based on mature technology. It has I don't know, 30 years of research behind it. And yeah, here I would also claim if you are looking for some document store, then this relational database should be your first choice. Just because it has like much more features than like regular NoSQL databases have. And I didn't like defend this point directly, but like our experience with performance tests also show that like even those like kind of abused and bad techniques, well, the database can still perform quite well. So that's all I wanted to tell. So self-advertisement. So there is like a GitHub repo where I have put some of the SQL scripts, and I will add some more during the probably next few weeks, because I am preparing for some internal training on the subject. And yeah, so then please leave the feedback. If you are in doubt, then the green card is the right one. And these are the sponsors of DevClub and Tieto. Yes. So, any questions about the content?
Could you please explain more concrete which one document database you used, KeyValue?
Which kind of like database?
Yeah, it was MockReduce, Tuxedo.
No. It was everything on top of Oracle. The idea is that these are Oracle tables with the exact same structure.
Okay. How you implemented JSON documents, indexes, etc.
It's everything supported in Oracle 12.
Huh?
Yeah, so that's like a new feature. Except if you try it at home, then please go to Oracle support and install like some patches, because this JSON support in like default version was pretty horrible. Especially like JSON path was had like many limitations, and I had like here I had even more issues, but like sometime like recently the Oracle support told me to install those patches, and those problems went away. So.
And the application logic was implemented in stored procedures? So
No. So it's a very old decision. So that the database is just doing queries like SQL statements, and the whole application logic is implemented in this Oracle Tuxedo application server in C++. So I know like decision 15 years ago was that, because like we know how much Oracle database costs, right? You can imagine. Now, at that time, this Tuxedo application server was owned by a different company, and it was really, really cheap compared to Oracle database. So we decided to move all the processing to Tuxedo, so to reduce the need for like database CPU. But now Oracle bought Tuxedo, so it's the same price tag, and maybe it's not as good decision, but it's still. Well, you heard the first talk, right? There are like many problems in testing this PL/SQL code. I don't think it's a particularly good development environment. It's more like a COBOL. No, okay, it's like you can write great code in it, but you can also write like really, really bad code in it.
Just like as in all other
Like
languages.
yes, like in any language. So we had like previously we had some code written in PL/SQL, and there are some patterns that PL/SQL programmers constantly do. Yeah. So my my biggest disappointment is that you can't do like normal data structures in PL/SQL. It's like we use caching a lot, and then you have to like do it then in like some PL/SQL tables indexed by. It's not great.
Any questions? No? No? Okay, thank you. Okay, paldies.